reflections has to look right. The materials have to be physically based. So when light strikes it, it creates the right appearance. The reflections are dynamic. It's flowing over the car. There's global illumination, soft shadows, the little tiny creases, reflection and refraction off the windshield. This image is so subtle, it's simply not possible to rasterize it. Well, as it turns out, what you saw just now, it was not a movie. It's completely in real time. Ignacio? This is the work, again, of some amazing engineers and artists. We work so closely with the team at Unreal, Epic, and the Unreal Engine team. Kim and his team did just an amazing job, as they always do, and the engineers at NVIDIA working closely together, and the Porsche designers that were part of this project. They're so proud of it. I mean, this is just utterly shocking. Ignacio, what else can we do? Area lights, the soft shadows across the area light. Look at that. Everything is completely real time. Global illumination. You could see some of the light just leaking right into the cabin. Wow. What else? Dynamic reflections. Can't do that with rasterization. No, look at the reflection off the windshield. Everything is all ray traced. Is Kim there? Where's Kim?
Yeah.
Kim, what do you think?
Unbelievable. You know, I've been in computer graphics now for 27 years, and it was a dream to see real-time ray tracing come true. And I think over the next decade, we're going to see such amazing capabilities of your hardware, powering, interactive experiences, movies and games. They're going to look the same. Photorealism, absolute photorealism is within our grasp now. It's amazing.
Kim, that's just amazing work you guys did.
Thank you.
You know, all of a sudden with this new computing, this new rendering model, the number of new algorithms that are going to come about, the new techniques for rendering is going to be reinvented again. It's just, the energy around all of our computer architects are just so high right now because there are all these, it's just a new toolbox, a new tool in the toolbox that's so powerful. You guys are going to come up with amazing things together.
Yeah, and honestly, it's gone. And I think AI for ray tracing, AI for computer graphics is also going to revolutionize the possibilities. So I think we're going to get movie quality within this new generation of cards. I think we're going to see movie quality in games as well as more enterprise-like applications like this.
Well, we've got a lot of horsepower for you, Kim. Do you know how many rays we could do? That's right, 10 Giga Rays.
10 Giga Rays. Yeah.
Do you know how much AI we could do? 500 tops.
500 tops.
That's right. And the shader, it's got independent floating point and integer processing. 16 flops and 16 tips.
16 tips.
16 tips. I love you, man. You're awesome. That's just amazing, guys. Isn't that beautiful? The work of Epic, they're just amazing. If you would have projected from DGX Station to where we would have finally expected to see this on one graphics card, we expected something along the lines of 5 to 10 years. Something along the lines of 5 to 10 years. Because of two fundamentally new technology, we were able to bring it to today. And those two technologies is exactly what Kim was saying earlier. Ray tracing acceleration with the RT core, and then deep learning with the tensor core. By combining those two technologies with what we did before, rasterization and shading and compute, all of a sudden we gave ourselves just an enormous boost, and we pulled in ray tracing somewhere between 5 to 10 years. And everybody is surprised. Everybody is shocked. All the developers we're working with, it's just amazing that we can basically cast as many shadows rays as we want. Reflection rays and refraction rays are much, much more expensive, but even then, we could cast a whole bunch of them. The ability to be able to do ray tracing at 10 giga rays per second is really, really quite powerful. The performance, when you compare that with what we're currently experiencing, so this is what you're looking at on top, is essentially what you would get if you had DGX Station. The architecture that's inside DGX Station for computer graphics is essentially what you're looking at, Pascal. Okay? And with some of it is used for rasterization, some of it's used for shading, and a lot of it is used for tracing the rays. A lot of it is used for tracing the rays. There's a few technologies that when in combination in this RTX platform, when you put them together, does this. Isn't that amazing, guys? A 6x speed up in computer graphics, a 6x speed up in computer graphics. Well, the way that it's done is we, number one, accelerate the ray tracing part of it. We still have to shade it, but the ray tracing acceleration is just incredibly fast. The second part is by using AI, we're able to render at a slightly lower resolution, but because we trained that model off of very high quality ground truth, we're essentially going to be able to generate the final image at a much, much higher rate. And so we call it DLAA. The combination of AI and ray tracing has made it possible for us in the Unreal Engine 4 with RTRT, real-time ray tracing, running on top of Microsoft's DXR API. This is basically today's most popular platform. We're able to take computer graphics and improve it by a factor of 6. Turing is 6 times Pascal. I mean, it's just incredible. Here, I love looking at that. You know, the engineers do all the hard work, and I just look at it like this. Incredible. You guys, great job. One of the most important things you'll see, and Kim was alluding to it, is that we're going to use AI in so many different parts of our graphics pipeline. One of them is anti-aliasing. As I was mentioning earlier, we use a temporally stable, not a temporarily stable, a temporally stable convolutional autoencoder. We teach this autoencoder from ground truth that was generated from 64 samples, jittered samples of a rendering. Imagine, it's basically, you render the same image 64 times, we jitter the samples, and then we use a very high quality filter, and we combine it all together into one, and it becomes one frame of a ground truth. We create a whole bunch of those, and we teach this neural network how to take an image and generate that. We teach an AI network, after we're done training it, you'll give it an image, and it will automatically generate a much higher quality image. As a result, we could start with a lower resolution image, and the result is a higher quality than a higher resolution image. Really, really quite amazing. The power of deep learning. High quality motion image generation. We call it the NVIDIA DLAA, and that's what you saw in action. As a result, the combination of ray tracing, faster shading, DLAA because of the tensor core, these 3 processors working together, Turing was able to accelerate the rendering time by a factor of 6. Architectural design needs photorealistic images. these scenes to an architect has to be photoreal so that they could convey the sensation of the environment to their clients. To do this is incredibly challenging, and the reason for that is because in most of these rooms, light is largely indirect. It comes in, it bounces around, and it picks up the nuances of the surface it strikes, and it bounces around until a full scene, what you experience to be a really natural environment. The light is indirect, materials are physically, obviously physical, and so they have different reflectance properties. And that gives you the sensation of a space. And so we're going to do that with computer graphics. Guys? So this is the Rosewood in Bangkok. And before we show you, this is really amazing. So we created this visualizer, this viewer. And it's connected to the Revit, in this case, and SolidWorks. Between SolidWorks and Revit, you could modify and edit right there in the tool, and it will show up instantly in the viewer. And the viewer is powered by RTX. Okay? And so Sean is going to be able to modify the building. This is the Rosewood in Bangkok. He'll be able to modify the building. He'll be able to place objects inside this building, and it will just show up in this viewer in real time. And then it's rendered on RTX. Sean, go ahead and give it a try.
Yeah, that's exactly right. So we can see we have Revit open there. We're looking at the lobby scene, and at this time of the day, there's just not enough natural light coming in. So why don't we open up some of those skylights, and we can see how that affects the illumination.
Now, obviously, you can't fake this. Obviously, this isn't baked into the textures, and the reason for that is because you just place the lights. And you can modify the lights. You could change the time of day and get a sense of the feeling of this room. Look at that. Wow. Marble looks like marble, that whatever that horse thing is made out of looks like whatever that horse thing is made out of. You know? I don't know what it is, but it looks right.
If we go a little deeper into the scene, we can see this kind of lobby feature here by the elevators. And it's kind of a great opportunity.
Hallways are obviously super hard, right, Sean?
So we can import an object here from SolidWorks and simply see how changing the materials in SolidWorks is actually changes the look and feel of the space.
This is Jeff Koontz's dog, shiny dog. We love shiny dogs. Wow. Wow. You guys see what's happening? I mean, this is just amazing. This is like having a wormhole between SolidWorks, Revit, and this viewer. It's just incredible. We love shiny dogs. Wow. Wow. You guys see what's happening? I mean, this is just amazing. This is like having a wormhole between SolidWorks, Revit, and this viewer. It's just incredible. Okay, is anything else? Shiny dog?
That's what we wanted to show for now.
That's beautiful. Look at the reflection of the sun right back there. It's just incredible, the bloom there. Okay, ladies and gentlemen, using RTX for architectural engineering and design. We worked with Autodesk's Arnold team, and they've been working with RTX, and they're just completely blown away. In no time ever has it been possible to render final film production on a GPU. And the reason for that is because it just wasn't fast enough. It wasn't fast enough, and it didn't have large enough frame buffer to be able to hold all of the assets. It wasn't fast enough because so much of the time is spent ray tracing. And now with global illumination, billions and billions of rays are being cast. You've got to trace the shadow rays, but you've got to trace all of the reflection rays and all the refraction rays. And there's just so many bounces all over the place to simulate global illumination. As a result, GPUs were simply not possible to render these scenes. Well, finally, with RTX, we've been able to do so. What I'm about to show you are several images of a shot. Now, if I showed you the shot, it would just look like a movie sequence. And so I'm showing you several images of a shot, and every one of these shots, every one of these frames were rendered, on the Quadro RTX. Final film quality for the very first time. This is what motion blur and all. This is what you get. This is what you get when you have the world's first ray tracing GPU with 48 gigabytes each. And if you connect the two of them together with this incredible technology that I'm wearing called NVLink, you get 96 gigabytes of frame buffer. And that captures about as large scenes as most do. And so, for the very first time, we're able to ray trace final film production quality assets. Well, we created a server called the RTX server. And it's designed for production rendering with full global illumination. And this production server is really quite amazing. This one server with 8 GPUs, will allow you to speed up your final film rendering. And it's designed to be remoted. It sits in a data center. It could be your render farm. It could also be your workstation. It could be your RenderMan workstation. It could be your Maya workstation. It could be your Nuke workstation. Every single application in the DCC universe is compatible with the software layer that we created called Quadro Infinity. You can put this in your data center, it becomes your workstation, and whenever you're not using it as a workstation, is your render server. The rendering time goes down from hours to minutes. And so let's take a look at what that means. Suppose, most of these data centers, as you know, these render farms, most production, it's not unusual for production costs to be $100+ million. And 20% of that, $20 million of it, is very typically assigned to the render farm. I'm showing you here just $2 million, 1/10 of a render farm. This is not quite a farm. This is probably just a garden. Okay? So this is a render garden. Now, no feature production could do with such a small server farm. But I'm just going to show you this little part for illustration purposes. 240 dual CPU, 12-core Skylakes, 144,000 watts, $2 million. That's what you're looking at. If we wanted to have the same throughput on the RTX server, this is what it looks like. You guys ready? This is before. This is after. This is before. So this. You can't even call this a garden. This is just your planter box. Okay. This is your personal render farm, and it's just a fraction of the cost. It only costs about 1/4 as much. It takes 1/10 the space, and it takes 1/10 the power. Each megabyte, each megawatt of power, is $1 million a year. Each megawatt of power is $1 million per year. And so most data centers have 10, 20 megawatts, and so you could imagine the cost as it goes forward. Saving money is one reason, but as we know from Blind's Law, whatever the budget is, the DP is going to want to use that full budget to maximize their creativity. And so let's take another shot at this. Suppose you had a constant budget of $500,000. You had a $500,000, okay? And so you had one server rack here for $500,000, another one for $500,000. You get 4 times the performance. Now, the reason why it's so amazing is because each one of those DGXs allows you to create a 3-second shot. Most shots are about, call it 2 to 3 seconds, about 75 to 125 frames. Those shots now take 1 hour. Instead of a shot taking 5 hours or 6 hours, it now just takes 1 hour. You could do a shot right before you go to bed, go to lunch. You could do 6, 7 shots per day. So the number of iterations is just really quite remarkable. It's going to completely change how people do film. The excitement from the DCC, the ISVs have just been incredible. Adobe Dimension is working on integrating RTX. Autodesk Arnold, Pixar RenderMan, Chaos V-Ray, Weta, all integrating RTX. All of the DCC tools, CATIA, Siemens NX, NSX, SolidWorks, integrating RTX. The number of software developers that have come out to embrace this platform is like nothing I've ever seen. And the reason for that is this. Everybody is under the constraint to deliver photorealistic images. Global illumination is now the bar. And we need to do global illumination in a physically based way that allows us to generate photorealistic images. The Quadro RTX starts at $2,300. RTX 5000, all of that capability, accelerating rendering for final film, the ability to generate photorealistic images for architectural engineering and construction, DCC, generating photoreal images, not to mention real-time ray tracing for video games and interactive content. RTX 5000, 16 gigabytes, 32 gigabytes with a NVLink starts out at $2,300, 6 Giga Rays per second. The 6000 is 24 gigabytes and 48 gigabytes if you use NVLink, has 10 Giga Rays per second, $6,300. And then finally, the monster, RTX 8000, 48 gigabyte frame buffer. It's just gigantic. It's like 4 times the size of a high-end Quadro board today for just $10,000. It's a steal. The important thing to remember is this: the more you buy, the more you save. The more you buy, the more you save. Every single world-class global system maker has jumped onto RTX. You're going to have workstations, amazing new workstations. You're going to have servers of all different sizes. 1 GPU, 2 GPU, 4 GPU, 8 GPUs. They're going to come in all different sizes and shapes. Quadro RTX is going to be available all over the world. So this is it. NVIDIA Turing, graphics reinvented. There's no question in my mind, this is the single greatest leap that we have ever made in one generation. This is the most important GPU we've created since NVIDIA CUDA. Turing delivers 6 times the performance of real-time ray tracing over Pascal, the highest performance GPU in the world today. The Quadro RTX 8000, 6000, 5000, the world's first ray tracing GPU, supporting a complicated stack that has been integrated into ISVs all over the world. The Quadro RTX systems allows you to do 7 shots in one day. 7 shots in one day. Who doesn't want 7 shots in a day? And then for the very first time, after all these years, we've been able to build something that the visualization industry, the $250 billion visual effects industry, for the very first time, we can enable them to be accelerated so that we can change their workflow, so we enable them to do more with the same budget. What do you guys think? Well, we have one more surprise for you. The guys have been working really, really hard on this. What you're about to see is completely in real time. You're going to see reflections. You're going to see inner reflections. You're going to see wonderful shadows from area lights. You're going to see ambient occlusion. You're going to see the effects of global illumination. Everything is going to be dynamic. You're going to see physically based materials, so the materials look real. You're going to see everything, and it's going to be in real time. Everything is in real time, running on a Turing. This is what the new Turing can do. Before I say goodbye, I want to thank all of you for coming to our launch. We're so excited about the Turing launch. I appreciate the support of literally every single developer in the DCC industry. The embrace that you have given us for NVIDIA RTX is nothing short of astounding. And the reason for that is I believe you all see, for the very first time, we could take a giant leap and redefine what computer graphics is. Computer graphics will never look the same again. It'll never look the same again. And the support has been phenomenal. So I want to thank all of you for that. I also want to thank all of the audience who are the pioneers of this industry. Because of the work that you have done, it has allowed us to stand on your shoulders to create what you see today. So ladies and gentlemen, I want to thank all of you. Thanks for coming to our launch. The team is going to show you something that is utterly unbelievable.
Like and share if you enjoy the video and think others might benefit from this, and of course subscribe and hit the notification button if you are new to the channel and want to be notified every time I post a video.